Welcome to video number 4 in our Blind 75 series. And we're going over problem 4 right now. And problem 4 is part of the hash maps and array problems. And it is called anagram groups. The basic premise of this problem is that we have a list of strings, list of strings. And what we need to do is we need to group group anagrams from these words into sublists, basically, as you can see on example 1 and how a list is created, turned into 3 sublists of anagram, and each sublist containing anagram words from that list. So there are multiple ways to solve this problem, basically, but we will probably go over both of them, and mainly though, what we need to understand is that before we go into the most optimized solution for this problem, we'll be going over basically the first method, which is more so of a more intuitive method than the method number 2, which is more optimized. So let's work on method number 1, which is basically the more intuitive method and the easier method, basically. So presumably we can see here that we have words here like act, pots, tops, cat, stop, and hat, right? So the first logic is basically, if you're not familiar with anagrams, just to be quick about it, anagrams are words which have the same characters, the same alphabets, same alphabets in them, and they are basically just the different orders of the same alphabets creating different words, basically, right? I think I wasn't that clear about it, but you can quickly pause the video and look that up. But basically, anagrams are words which have the same characters in them, but their order is different, right? So act and cat are both anagrams. So based on that premise, because both have the same words, but it's all right. So based on that premise, right? How can a computer algorithm identify anagrams, right? It's not like it has an intuitive mind of its own like us to identify, hey, act and cat, they have the same letters, so that must be an anagram, right? They don't have that. They don't know what an anagram is. We need to come up with a logic that is able to identify anagrams. And the most easiest of that logic is the first word is to basically save all of the go over each of the strings and sort their characters by alphabetical order. So potentially, if we have act here, that's the first word here that I was talking about. If we have the word act here, right? Uh, give me a second. Let me a little more cleaner. So we have the word act, right? That's the first word. But act has anagram cat, right? So act is already uh, sorted in alphabetical order, but cat isn't. So what it would do is, because cat is its anagram, you'll notice that when we sort cat by alphabetical order, what would it become? And I'm pretty sure most of you would have guessed it by now. It would also become act. So this way, when we sort these words alphabetically, they become exactly the same. And that is one logic that we can implement. That's the more intuitive logic that we can implement to solve this problem. Similarly, just to give you another example, we have stops, spots, and tops. Those 3 are anagrams of each other, right? So let's start with stop, right? So let's see. O, I think, comes first, then P, and we're talking about alphabetically, right? Then P, uh, then S, and then T. It doesn't make sense to you, right? But it doesn't need to make sense, right? Because ultimately, it would make sense to a computer, right? So we arrange stop like this. We'll arrange pot like this as well. And we'll arrange tops like this as well, right? So once we arrange them, all of these 3 words would look like OPST. right? It doesn't make sense to us, but it makes sense to the computer. And once the computer knows, hey, all of these words are the same, when sorted alphabetically, it would group them together as anagrams. So that is the intuitive logic of method number one. So now let's just go over more so than the intuitive logic, more so let's go over the coding logic of this example. So based on that, let's go over our approach for this problem. Let's set our approach for this problem, right? So first we need to sort each string and its characters. If the two strings are anagrams, their sorted versions will be the same. That's something that we just proved, right? And number two, we'll be basically use a dictionary to group the strings together, and the sorted version of the strings will be the key, and the corresponding values will be the list of anagrams. So what we're going to do is to keep a record. We're going to create a dictionary where the sorted version, which is basically OPTS that we just created, or ACT on the other list, as the key. These sorted words would be the key, and the values within that would be all the characters who sort out which sort to become that key itself. So that's how we're going to store the value. We're going to do 4 steps on this problem. First, we're going to initialize an empty dictionary called anagrams dict. Then where the key would be sorted, key will be the sorted version of the string. Then we're going to create each string in the input array, sort the string and use it as key. Then we'll append the original string to the key to list the corresponding to the sorted key. And finally, we'll return the list of all values from the dictionaries, which are list of anagrams. So with that out of the way, again, like one of the methods that I use is to write down pseudocode of all the steps that I want to do to solve a problem, and then just copy paste that pseudocode as comments into the screen, and just write after that comment the related logic to that particular pseudocode that I write, which is basically step-by-step coding logic that's in my head before I actually write down the code. So with that out of the way, first we need to create an empty dictionary. Basically, what that does is it makes sure that we can save our sorted key value pairs in that dictionary. So let's create the dictionary first. With the dictionary out of the way, then we need to go start with our first pseudocode for this problem, and which is basically, simply speaking, iterate over each string in the input list. And for that, we just write a simple for loop that iterates of the strings of a single string in the stars word. So that's our for loop. Then we have another pseudocode that is for the one of the two logics that are going to be in the for loop, and this is to sort all characters in the string. So for that, we just simply use the sorted function and join that together with no gap in between. You'll just see how I write that down. I won't go into too many explanation. I'm pretty sure at this point, if you're working with blind problems, you understand what Python code means basically. So let me and logic is more important at this stage than the step-by-step explanation of what the code is doing. So this particular step, basically, we're just going to sort the characters using the following Python code. We have the variable names called sorted string, and within that variable name, we'll just use our logic here and our code here to sort the values and join them with no space in between. That out of the way, then we move on to the next logic of this particular problem, which is we need to use the sorted string as the key in the dictionary, and based on that, we need to make certain decisions, right? So what do I mean by that, right? So if the sorted string a value that we just sorted is in the anagrams dict, right? So basically it's already there, then we append the value to that particular key. But if it isn't there, then we just add a new key in that dictionary basically. So let me write out that logic. This is going to be a control structure using an if-else statement. We have that in the way. Now we're going to append this to the string. Append the string to this. Now, if that isn't the case, the opposite would be true. With that, we'll move on to the last of our pseudocode, which is return all grouped anagrams as a list of lists. So as we have already sorted this as needed, we exit the if-else control structure, we exit the for loop, and within that, we write our next pseudocode, which is return all grouped anagrams as a list of lists. So we return the anagrams dict using the dot values method and convert that using the list built-in method. So let me write that down. All right, let's just run this code and see if this works. Yep, and both case 1 and case 2 are working now because this particular example works. But again, at this same time, you need to understand that this particular example, basically, the sorted version is used as a key. For example, act, cat have both the for from act, so they're grouped together, and act is the key for act and cat both. And if the sorted version already exists as a key in the dictionary, the string is appended to the list, presumably, and then we return all values as a list of anagrams, right? But again, you need to understand the time and space complexity of this problem as well, and they are abysmal, basically. And that is why this is probably not the optimal solution that you want to use. So sorting each string takes OK log K, where K is the length of the string, right? So for each string, it takes OK log A. We do this for all n strings, so the overall time complexity becomes even longer. So it's O nk log k, where n is the number of strings and k is the maximum length of the string, right? So with that, this becomes a very time complex algorithm, basically, to solve this problem. At the same time, space complexity is also O and K because we store each string in the dictionary and the sorted versions as keys. So this is a very, very inefficient way to solve this. So there's an alternative approach to solve this as well that uses hash maps. And because the whole theme of this particular section of Blind 75 is hash map and arrays, that is the most optimal way to do this. But the reason we went over the previous example is because simply said, we need to understand that there's a more intuitive way to do this as well that helps you understand how what this problem is and how you can solve this problem easily. Now that you have that intuitive understanding, right, let's move towards the alternative solution that uses hash maps without sorting the strings. Instead of sorting, we use character frequency of each string as the key for grouping anagrams. This avoids the cost of sorting the strings and instead builds up a frequency count of characters for each string, basically. So what we basically would be trying to do here is that we have a character frequency for each of the string. We create a count for each character like a histogram. And for example, if we have the string act, as we discussed before, and cat, both have the same character frequencies of 1a, 1c, and 1t. And then we use a tuple of 26 integers for each letter a to z to represent the frequency of characters in a string, basically. And the tuple will serve as the key to the dictionary. So, and we group the strings in a dictionary where the key is the tuple representing the character frequencies, and the value is a list of strings that match that frequency. So here it is, right? Let me break that down in a little more digestible form. Let me delete the method one that we wrote about previously, and let's move to method two. Let me click the pen and let's start writing method two to solve this problem, and probably the optimum way to solve this problem. So what we need to understand here is that every word has a character frequency. What do you mean by character frequency? So act is the first word, right? Again, like we're going to use act again, right? Act and cat, those are two words that are similar to each other, right? So let me write cat as well. So instead of sorting all of these out and increasing the time complexity of the problem, what we do instead is we pick up act and say, hey, A is used, how many times A is used in act, right? So A is used once, C is used once, and T is used once, right? So all of these are used once in this. Similarly, if we look at cat, it does the same thing. And act is already doing the same thing, right? So what does this mean? What does this mean? This means is that if the character frequency of the words is the same as each other, there's a very likely chance that they're anagrams. In this example, we're going to presume that is the case, right? So after that understanding, we understand that we use a tuple as a key of 26 integers, right? For each letter A to Z, we represent the frequency of the characters in a string. And the tuple will serve as the key in the dictionary. So the way you can understand is that this particular portion that we have, the frequency count that we set up, we set this up as a tuple, right? And we save values of these words within this tuple in a dictionary to create a hash map. A dictionary is a hash map, basically. So this becomes the key, and these become the values. So this way we can easily group them together and then convert them to sublists and lists in questions, right? And get this done basically. So that is basically the logic behind this. So now that we understand the logic, we've already solved this problem here using the previous easier method. So let's just delete this logic here and move towards the more efficient method and write that down, right? So before we move that, let's again go over the steps for that, right? So we initialize an empty anagram dictionary here as well, right? That's the same as previously. Then we, for each string, we compute its character frequency and use the tuple of the counts as key. We've already covered that. So we count the frequency of each word and make that a tuple, and that acts as a key to the hash map or dictionary. And then we append the original string to the list corresponding to that key. So once we look at the original string and see that it has the same frequency, we append that to that particular key in the dictionary. And finally, we return the list of all values from the dictionary, which are lists of anagrams, basically. So pretty much makes it simple enough to understand. Let's initiate the empty dict again. Give me a second. We have the empty dictionary ready. It's the same one. Might as well have left it from the previous space, but didn't leave that. So let's just move on to the next step. Next thing is we need to, again, like I'm going to paste my pseudocode as comments and then write code below that. So the next step for us is basically we need to iterate over each string in an input list, basically. So again it's similar to the one we did previously. So for string in strs, and you'll be thinking, where does the strs come from? Strs comes as an argument in this function itself, right? So when we have that, next we need to look at our next pseudocode, which is create a frequency count for each character and 26 alphabets in 26 letters in the alphabet, basically. What do we mean by that? So what we need to do here is create a frequency count. let me try to increase this here so you can see the entire screen. We have gone over the question, so let's just focus on the solution right now. So as you can see on my screen right now, rather let me open the solution a little bit. So yeah, as you can see on the screen right now, we need to get a frequency count for each character that we store, right, in a letter. So first we need to basically create a char count, right? And to do that, let's just set that up. We're using 26 because there are 26 letters in the alphabet. So that is why 26 is being used here. Then we count the frequency of each character in the string. So once we have the char count there, then we create the frequency of each character in the string. Let me post the pseudocode here. And then let's write the string again. So we're going to count the frequency of each character. So it's going to be a nested loop, for loop within that. So we loop over each string in the strings, and then for within each string, we loop over every character. So for that, we're going to create another for loop. And within that, we update the char count variable that we created with +1 based on the value. So here, I'll show you. Let me set that up first, but I'll tell you what we're doing in more clarity once I write down the code. So you'll be noticing this is a little more technical and less intuitive than the previous one. We're writing more lines of code, so on and so forth. But a point you'll need to note here, it's not that difficult. So we're basically setting up a char count, but we're assigning basically reference to that, right? So we're deducting the character from A. What does that mean? The odd function basically pulls up the ASCII code of your particular character, right? And we reduce minus A. So we don't want the original ASCII codes, but we want pretty much our under the numbers from 1 to 26 instead, right? That's more understandable to us as a programmer. So here we're reducing A. Basically, what it means is that we're reducing all like let's say if we had a value of our character was supposedly let me just write this down. Just note what I'm doing here. So if we had a value of let's say 134, let's say that's the starting value, right, of character A, right? And our current value is, let's say, we're using B, right? That's 135, right? So when we deduct B from A, the value, the ASCII code value should be 1. So B is 1 digit ahead, right? So 1 is the value basically. So that's the reference code we're going to be using to refer to these values. And that's why we're deducting this value to create that reference. Based on that, now we need to go towards our next pseudocode, which is basically to convert the list or to a tuple so that it can be used as a dictionary key instead. So we enter that, and now we need to do that. So how do we convert a list to a tuple? The char count is a list right now. So we convert it to a tuple and give it a value of key. I think it's a little bit misaligned. Let me get the alignment ready. And we, we create a value equal t, then use the built-in tuple method and convert char count to a tuple, which is going to be used as a key that we refer to, right? So now that we have that, tuples are immutable, keep that in mind as well. So at this point, we wouldn't want to change the frequency. So use the frequency tuple as the key in the dictionary. So that's the next pseudocode that we need to set up. So let me get that pseudocode over here, and let's type our solution for that. Basically, we're going to write the if statement to a control structure to see if the key in the anagram dictionaries if the key that we just created is in the anagram dict. If it is, if key is in the anagram, we just append the current string to that key. Else, we just add that key to that particular dictionary, basically. So let me do the same if else statement, pretty much the same that we used previously. So let me write that down. Or that's the first aspect of our if else statement. On else side, we would need to add a similar statement, but just we're changing the value, adding the value to the dictionary here instead. All right, that should set up our if else statements. Now we exit the current for loop that we are in and return the values, all the group values as a list of lists as previously. So we get out of the else if else control structure, then we get out of the false, then we paste our pseudocode, and then we return this value as a list of lists as we discussed previously. So list, and then we set that up, and now we can see running the code if it works. And it works. So that is the second problem, the second way to solve this problem. And this is the more efficient way. The first basically gave you a foundation of getting better intuitive grasp at this problem. The second, but it was very, very inefficient. And the second one, though, is a little more counterintuitive to understand, but it is more efficient in its usage and the usage of computer resources. So generally speaking, let's just break this code, some key aspects of this code down as well. So we created a list of char count of size 26, basically of a 26 value, as you can see on the code. When we created char count, we gave it a byte space of 26 characters, basically. So it won't exceed that 26 characters, right? Where each index was corresponding to a letter's frequency in a string. So for example, for the string cat, it might look like 1 0 0 0 1, or sorry, for a string cat, it might look like 1 0 1 0 0, and right at the space where t should be, it would say add 1 there as well. So that's how we're referencing to the frequency. So it might look like 26 a list of 26 length, but every space is represented by how many frequency counts of that specific letter there is, right? Then we convert it to a tuple to make tuple as a key, as tuples are immutable and can be used as keys in dictionaries. The same key character frequencies will produce the same tuples for the anagram. Then we group the anagrams together. We store each string in the dictionary under its corresponding tuple key. Anagrams will have the same character frequencies, thus the tuple key grouping them together. So when we talk about the time complexity of this problem, we need to remember that counting the characters in a string takes O of k time, where k is the length of the string. Unlike previously, which was taking n log n, OK log k time, basically, which is based on the length of the string. So that was more. This just takes the time as much time needed as the length of the string itself. We do for it for all strings, so it's onk. So where nk is the number of strings and k is the maximum length of string. So it's much more efficient than the previous solution. Similarly, when we talk about space complexity, it is of onk because we store each string and character and frequency as a tuple. So with that, I think we've seen both solutions to this particular problem and how to solve each aspect of it. And with that, we're going to wrap this fourth video on Blind 75 problems up. And we'll see you on our next video with the next problem from Blind 75. Thank you.